Chapter 4 Quadratic Equation Assessment by Jovan G. Denota. So the first question was sketch a parabola that represents the height of the ball versus time. Show your initial height and the vertex clearly on the graph. Show all your work to receive full marks. So over here, to first sketch a parabola, the first thing I did was look at the equation. From here, there's two things. One thing I can determine. From here, I can determine that this equation is in vertex form. And from here, since I know that the equation is in vertex form, I can determine that I can determine the points of the vertex, basically, which is h and k. Since I know h is 3 and k is 25, I can determine the vertex. The points for the vertex will be 3 and 25. Next, to properly sketch the parabola, first I need a list of x and y values. And so since I did that, right? So once I've put a list of x and y values, I kind of put in the x values into the equation. So x will be represented by. So the x values are going to place of t, so it'll be h equals to negative 4.9 brackets negative 1 minus 3 bracket close, then x negative 2 plus 25, and then from there I find the y value. What these points represent are basically the points of the parabola on the graph. So basically, if you put all these points on the graph and you make a line and you join the dots or connect the dots, it'll basically form a parabola. And from there, that's exactly what I've done here. So as you can see here, this is the parabola I have formed. This is the y-axis, x-axis, time in seconds, height of the ball in meters. So over here, the first part of this question was, what is the initial height? So the initial height is basically when x is 0. So from here, if you look at the graph just itself before looking at the graph, when x is 0, the initial height is negative 19.1 meters. So I wrote here the initial height is negative 19.1 meters. Just for verification, if I look at the graph, and since I know that initial height is when x is 0, so when x is 0, go down here. Basically, I look for the point where the parabola intercepts the y-axis. It looks like it intercepts here near 19 and 20. So basically, really close to 19. Looks like it's 19.1. It's really close to 19. So it looks like it says between 19.1. So that's what it was. So that's why. So that's what the point was. And here, if you look closely, I've indicated that 0,19.1, which is like the exact point over which is the initial height of the graph. And since he said here, show clearly where the initial height is. So I've shown clearly on the graph, this is the initial height, negative 19.1. And then other question, what was the vertex? So the vertex. So from just looking at the equation, the vertex was negative 3 and 25, as h and k, h is 3, k is 25. When I look at the graph, I know the vertex is basically the highest point of the graph. So if I just keep on going up, this looks like over here-ish, looks like the highest point on the graph. Now if I go closely, look at the point. This looks like at 25, and then go down, looks like at 3. So I know the vertex is at 325. Positive 3, not negative. So it's at 325. So as you can see here, in conclusion for question 1A, I've indicated the vertex clearly, 3,25, and it indicated the initial height when x is initial height, negative 19.1 meters. And just for verification, I looked at my table of x and y value chart. When x is 0, which is initial height, is 19.1, and then just to verify that my vertex is correct, I basically looked at the equation, found the vertex, which is 3,25. Moving on to question B, it was, what is the maximum height reached by the ball? So what I wrote here was 25. So basically the maximum height reached by the ball, if I look at the graph itself, I can see the maximum height looked around over here. This is because this is where probably the ball started to fall down after it went up for a little bit. So maximum height looks like it was at 25. Just by looking at the graph, I can tell that the maximum height was 25. Also, just to verify, I can look at my table of contents, x and y values chart, and from here I can look on the y side. It looks like that it looks like it's negative 5.3, negative 19, positive 5, 20, 25. Then it starts dipping down. That just means that the ball had reached a height of 25 meters and then started going down. So that's why I wrote 25 there. Moving on to the back side of the page, question C was when did it reach its maximum height? So maximum height was basically reached at 25. Since I know the maximum height is 25, so let's figure out when it reached 25. So 25, looking at the parabola and going down here, looks like it was at 3. So at 3 seconds, it was at 25. And I can obviously verify that by looking at the vertex. The this is looking at the vertex point. So this represents x, and since I know x represents time and y represents what do you call it, a height. So I can clearly say that 3 seconds, that this 3 represents 3 seconds, and this represents the meters in height. That's how I kind of got 25, 25 meters. That's how I got 3 seconds for C, because I can easily tell by the vertex, since it's the highest, since vertex is kind of meant to be the highest point of the graph. And question 1D was basically what's in height of the ball for 2 seconds. Easily look at the graph. 2 seconds, go up, 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 up. Let me go down here. Looks like it is between somewhere at 5, between somewhere at 5 or 2. Wait, my bad. If I keep on going up, over here. So if we look over here, it's somewhere between 20 and 21. Somewhere between those two, or I can say it's like about 21.1, and that's how I got the value for what it was, a 1D. What was the height of the ball for 2 seconds? I can look at the graph, put my finger up, go up, and look at where the parabola intersects 2. It looks like it intersects between 20 and 20 point. It looks like it intersects between 20.1, and that's how I got 20.1 there. Also, for further verification, so actually, when does it intersect? What's the height at 2 seconds? So x, which represents time, 2 seconds. To go to y, which represents height. Go down here, 2 seconds, 20.1 meters. So that's how I got 20.10 or 1 meters. So looking at question 1E, it's basically when does a ball reach the same height as D? The D's height was basically 20.10 meters, and so it's asking when does the ball reach 20.10 meters. I can clearly just look at over here, look at the graph, and go up here, 20.10. So over here, look at the graph. Basically, whenever this line intersects the graph, go down here. It's at 2. So intercepts it at 2 seconds. Yeah, one thing I forgot to say for 1A was that after looking at points, all it is plot these points onto the graph and basically connect the dots, and that's how I got the parabola if I didn't indicate that already. Coming back to question F, I know that the question says when does the ball land? So from here, the information that I know is that the ground level, basically when the ball hits the ground, is at 0 meters. That's basically when the ground is at 0 meters. Since I know it's at 0 meters, that means that since I know it's at 0 meters, that means that the y value must be 0, because the y value kind of represents the meters, and since the meters is 0, that means the y is also 0. Since I know the y is also 0, 0, all I have to find is x, which is seconds. So all I have to find is what time does the ball land. That's ball that hit the ground. What time does the ball hit the ground at? So basically, all I have to do is find what time the ball hits the 0 meter mark, or 0 meter mark. And to do that, all I did was grab the equation, substitute h for 0 because that's height, and I know that the ground level is at 0 meters. And then all I have to do is find t, time. So from here, I did some mathematics stuff. So all I have to do here was bring all the constants on one side, then bring all the constants on one side, leave the variables on one side. So over here, all I did was bring 25 here, which became negative 25. And then all I did after that, I decided to bring negative 4.9 over here. And to do that, I divided both sides by 4.9. So a negative and negative equals positive, so it equals 25 over 4.9. And over here, since I want to get rid of the square root and in order to solve the brackets, all I did was square root the brackets, which gets rid of this. Technically, you should get rid of the square root. And since I square root one side, I have to do the same to others, so I square root this side also. From there, the answer t minus 3 equals to 2.258. And next, I isolate t. To do that, I'll have to use plus 3 over here, which equals t equals to 5.258. That means that the time, so all this math indicates that at 5.258 seconds, the ball hit the height of 0 meters. In the question, in this context, that means that at 5.2 seconds, that's the time when the ball landed on the ground. So that was basically the process of what I did to get the answer. And basically, all you asked here was rounded to 2 decimal places. And right here, as you can see here, 5.258 equals to 5.26, where I rounded to 2 decimal places. For question 2, I chose set A. And for question set A, 1, the question was that the zeros are a parabola of 1 and negative 5. On the y-intercept is negative 7. find the equation. Pretty easy here, but just tell me that the zeros are parabola 1 and negative 5. I instantly know that the equation must be in factored form, as the factor form is basically the only equation which involves 0, from my understanding. So basically the factor form equation is this: y equals to a in brackets x minus r in brackets again x minus s. So from here, looking back at the equation, I know that the zeros are 1 and negative 5. That means that the r and s of this equation, r and s, are negative 5 and 1. Basically, all of us substitute negative 5 and 1 into this equation, which became out to be positive 5 and negative 1, because negative equals positive and positive negative equals to negative. And from there, if you look at the equation itself, I'm missing 3 values: y, a, and x. And I had to find those 3 values. But first, if I look at the question again, I was missing one key information, which was the y-intercept, and that's given to me. This basically means that this y-intercept means that the parabola intercepts a point, which is the parabola is basically the parabola intercepts a point of the y-axis, which is negative 7. From this, I know that the point itself would be 0, negative 7. So that's why if we look at the second part of this to find a, was that if you look at the third part right over here, 1, 2, 3, third part over here, I substituted y for negative 7 and x for 0, because you already have given or told me that the y-intercept is negative 7, which means 0, negative 7. But that means that x is 0 and y is 7. That's that's basically the point where the parabola intercepts the y-axis. And from there, I figured out what the y value is and the x value is. All I'm missing was the a value. To find the a value, all I have to do is some quick math. So all I have to do is basically right here, isolate a. First, before isolating a, I'd do some math over here. 0 plus 5 and 0 minus negative 1, which equals to 5 and times negative 1 times a, which equals to negative 5a. And all here, I'll just isolate a, and to do that, I just divide it by negative 5, divide this by negative 5 too, because whenever you want this side, I have to do it on the other side, which came out to be positive 1.4a. From here, I've acquired 3 key pieces of information: that 1.4 equals to a, r and s are 5 and negative 1. And from here, I can make out what the equation is. So the equation in the end was y equals to 1.4 in brackets x plus 5 in brackets again x minus 1 in brackets. So that is the equation of the quadratic relation of question 1a set a. Question 1 set a. Now moving on to question 2. Over here, they give me an equation, and from here I find the zeros. It's pretty easy. I know the r and s, which are basically the zeros, are negative 3 and 9. All I have to do is flip the values. Flip the signs, which equals to 3 and negative 9. So the answer to 2a is 3 and negative 9. So for question 2b, the first thing I find is a vertex. Pretty simple. All I have to do is take the zeros, find the midpoint of the zeros, which became negative 3. Put that negative 3 into the x value of this equation, over here. Put 0 into substitute 0 for x. After doing that, I found out the equation basically became y equals to negative 2 in brackets negative 3 minus 3 in brackets again negative 3 minus 9, plus 9. And from there, after doing some math, I figured out that y equals to negative 2 times negative 6 times 6, which equals to y equals 72. And since I know that x equals to negative 3 and y equals to 72, I basically found the point of the vertex, which is negative 3 and 72. So the point of the vertex is negative 3 and 72. So for question question 2c, you asked me to sketch a graph that clearly shows the zeros in the vertex. This question is pretty easy. So the first thing I did was look at where the zeros are, plot the zeros onto the graph right here. 9, 0 over here, 3, 0 here, and label them as these are the zeros, as you said, to clearly label the zeros. Next, look at the vertex, the points for the vertex. Plot the points for the vertex on the graph right here, and clearly indicate that this is the vertex. So negative 372, negative 372 is the vertex. Then what I did was, I could have just connected the dots, but what I did was, just to make sure, I created a table of values. And I created a table of values by using this equation. Basically, apply the x values into this equation, and to determine the y values. And by doing that, I plotted these values onto the chart, on the graph, and connect the dots, and that's how I got the graph. The test was completed under 40 minutes, so I think they were around like 35 to 36 minutes. I'm not sure. It took me that much time